The AC to DC converter utilizes 3 silicon-controlled rectifiers, or SCRs, and 3 diodes to form a 3-phase bridge rectifier. To understand how the AC to DC converter works, let's explore the simplest semiconductor device, the diode. Oddly enough, the direction of the diode symbol's arrowhead points against the direction of electron flow. This is because the diode symbol was invented by engineers who predominantly use conventional flow notation in their schematics, showing current as a flow of charge from the positive side of the voltage source to the negative. This convention holds true for all semiconductor symbols possessing arrowheads. The arrow points in the permitted direction of conventional flow and against the permitted direction of electron flow. For this discussion, conventional flow notation will be represented. The diode functions in similar fashion to a check valve. They open and allow flow if the pressure across them is of the correct polarity to open the gate. If the pressure is of the opposite polarity, the pressure difference across the check valve will close and hold the gate so that no flow occurs. Like check valves, diodes are essentially pressure-operated devices. Similar to the check valve, a diode restricts current flow to one direction only. As shown here, when a diode is used in a completed circuit with a positive voltage connected to the anode and a negative voltage connected to the cathode, the diode conducts and current flows through the diode. This state is referred to as being forward biased. When the diode is used in a completed circuit with a negative voltage connected to the anode and a positive voltage connected to the cathode, the diode does not conduct and no current flows through the diode. This state is referred to as reverse biased. The silicon-controlled rectifier, or SCR, is a semiconductor device that is similar to a diode except that it has 3 electrodes, an anode, a cathode, and a gate. If we continue to use the check valve analogy, by adding a spring-loaded latch to the check valve, we must not only apply a pressure or flow in the normal direction of flow, but we must also pull the spring-loaded latch to cause the valve to open. As with the diode, applying a pressure or flow in the opposite direction will cause the valve to close and flow to stop, but the spring-loaded latch must also be released to maintain the closed valve. When a positive voltage is applied to the anode, a negative voltage applied to the cathode, and a positive voltage is applied to the gate, the SCR conducts and current flows through the SCR. To stop the current flow through the SCR, a negative voltage must be applied to the anode, a positive voltage applied to the cathode, and a negative voltage applied to the gate. To understand how diodes and SCRs are used in a rectifier circuit, we will need to examine how a diode or SCR placed in an electrical circuit acts on an alternating current sine wave. In a simple circuit, during the positive alternation or first half cycle of the AC sine wave, A is positive and B is negative, allowing the positive alternation of the AC sine wave to pass through the circuit. During the negative alternation or second half cycle of the AC sine wave, A is negative and B is positive, allowing the negative alternation of the AC sine wave to pass through the circuit. As you can see, applying an AC sine wave to the simple load circuit has no effect on the AC sine wave. Now let's see what happens when we place a diode in the same circuit. During the positive alternation or first half cycle of the AC sine wave, A is positive and B is negative. The diode has a positive voltage on its anode and a negative voltage on its cathode. Current flows through the diode, allowing only the positive alternation of the AC sine wave to be converted. During the negative alternation or second half cycle of the AC sine wave, A is negative and B is positive. The diode has a negative voltage on its anode and a positive voltage on its cathode. No current flows through the diode, and the negative alternation of the AC sine wave is blocked. This is known as half-wave rectification. As the name implies, a half-wave rectifier produces only one positive half cycle and blocks the negative alternation of the AC sine wave. A full-wave rectifier is able to produce a positive half cycle for both the positive and negative half cycles of the AC sine wave. In this example, we will use 2 diodes and 2 SCRs. The only purpose for the SCRs is to provide a means of turning the rectifier on and off. The rectifier would work just as well using 4 diodes. During the positive alternation or first half cycle of the AC sine wave, A is positive and B is negative. SCR1 has a positive voltage on its anode and D2 has a negative voltage on its cathode. Current flows through SCR1 and D2, and the positive alternation of the sine wave is converted. During the negative alternation or second half cycle of the AC sine wave, A is negative and B is positive. D1 has a positive voltage on its anode and SCR2 has a negative voltage on its cathode. Current flows through D1 and SCR2 and the negative alternation of the sine wave is converted. Now that we've covered the basic rectifier components, let's see how they work in the 3-phase bridge rectifier. The 3-phase bridge rectifier circuit has 3 legs, each phase connected to one of the 3-phase voltages. Alternatively, it can be seen that the bridge circuit has 2 halves, the positive half consisting of the SCRs, 1 SCR, 2 SCR, and 3 SCR. The negative half consists of the diodes, D1, D2, and D3. At any time, one SCR or diode from each half conducts when there is current flow. If the phase sequence of the source is ABC, the SCRs and diodes are sequenced 1 SCR, D3, 2 SCR, D1, 3 SCR, and D2 repeatedly. Keep in mind that the 3-phase voltages A, B, and C are separated by 120 degrees. During the positive alternation or first half cycle of the AC sine wave of phase A, one SCR is conducting. At this time, phase C is in its negative alternation, causing D3 to conduct. This sequencing takes place for each phase of the 3 phases as demonstrated. As shown here, the sequencing of the SCRs and diodes produces an unfiltered DC from the 3-phase AC sine wave.
Thanks for watching. Please do subscribe us at UA Technical Solutions.